Alright, so this is the river crossing assessment. And we're having that our boat at top speeds can go 24 meters per second across the river. And the river has a... I'm doing a video for AP Physics. You're good. You're good. So the boat has a top speed of 24 meters per second, and the current of the river is 7 meters per second. And the first question is, at what speed and angle relative to straight across does the boat look like it's traveling to an observer on the shore? Please include an appropriate vector diagram. So, if I were to draw a vector diagram, let me keep the colors appropriately matched. Oops, sorry. So, vector diagram. So vector diagram for this particular problem, I know that the speed of the boat would be 24 meters per second. And that would be like this, straight up, just like in my picture. And the current is providing a down the stream, so it'd be a 7 meters per second to the right. Sorry, that's kind of not straight. So, seven meters per second. And then the last speed, this part right here, would be the velocity relative. It would be what our boat would actually be traveling. So this is the actual path the boat would take, because this 7 meters per second would affect the boat. It would not travel straight across, since there's this push from the river 7 meters down the stream. So this would be the actual path that our boat would take, and we're going to label that VR. And this would be, so VR. And arrows like that. And so we're going to try and find the VR. So if I use Pythagorean theorem, I can say that VR squared is equal to, I can say that oh, my bad. So VR is equal to the velocity of the boat. I'm just going to use the same colors. I'm kind of lazy here. Actually, so VR squared is equal to the velocity of the boat squared plus the velocity of the current squared. So once again, this is just Pythagorean theorem, and plugging and shoving numbers in. VR squared is equal to velocity of the boat, which is 24 squared, plus the velocity of the current, which is 7 squared, and the velocity of, take the square root of that, and VR is equal to 25 meters per second. So, whoops, okay, that's just 2 meters, that's a lie, not 2 meters per second, 25 meters per second. So that's the velocity of the, that's a VR, that's the actual path that it would take. And we also need to find the angle. So I'm just going to use a completely different color, because, alright, so for velocity, so the angle, we're going to use tangent theta is equal to opposite of adjacent. Tan theta is equal to 7 over 24. I'm just using two sides that I know for sure. So theta would be right here, and two sides I know that I've been given are the opposite side at 7 meters per second and the adjacent side, which is 24 meters per second. So, and then tangent theta is equal to 16.3 degrees. Oh, whoops. The theta is equal to tangent inverse 7 over 24. That'll give you an angle. And that angle comes out to be 16.3 degrees. So we found our velocity relative to the two velocities, and we found the angle at which it will be going across the river. And so the next question is, how far downstream will you land? How far downstream will you land on the far shore? So we're gonna do do it in red. Draw a line across. So across the river, we're going to use delta x is equal to velocity times the time. And I know that this delta x is, I didn't mention it, but 1,104 meters. So I can just plug that right in. And I know the velocity because I was given that, so 24t. And then from there, it's just basic algebra. It's not even, it's algebra, yeah. So time is equal to 46 seconds. And then the next, part of this question is, so this gets me across. I get across the river in 46 seconds, but it doesn't tell me how far down I'll actually be. So now that I know everything in that equation, I can say that delta x is equal to VT, and now I don't know this, how far down. I just know that the river is 1,104 meters wide. So delta x, and then delta x is equal to 7. Oh, okay. So, and the 7 would be represented by this 7 meters by the current. That the current is 7 meters per second is being supplied by the current. So 7 times, and the time was 46 seconds. And so, okay. I'm figuring stuff out while I'm doing this video. Okay, so explain this to you that I know what I'm talking about. This across is the only across the river velocity is being supplied by the boat. So that's why I use the velocity of the boat here and the across the river distance. But here, going down the river, it's 7 meters per second down the river, and the time I already found out. So delta x, yeah. So, and then delta x is equal to 332 meters. So this will be my final answer. 332 meters down the river. Downstream. And that's when I would be across the river. And then the next question is, at what angle relative to straight across would you have to point your boat so that you could land directly across? Please include an appropriate vector diagram. So the velocity of the boat, in this case, to get straight across, would have to be going in the opposite direction that the current is. And it'd still have to be going just in the opposite direction of the current. So it kind of looks something like this.
That's bullshit, man. You should call the police on that. Call the cops and tell them you broke.
Well, actually, I'm not gonna. It would be like this. It'd be like, but in a straight line. So the vector diagram would be like this. It'd be like the velocity of the boat, and then the current. So now, instead of it being straight across, it is to the up and to the left against the current, which is like this. VC, V current, and then our VR, which is our actual path that the boat will take, would be something like this, what we want, which is straight across. And so, like the previous problem, or two previous problems, the first problem, I can use Pythagorean theorem and solve. So VB, so velocity, the velocity of the boat is the hypotenuse, velocity of the boat squared, is equal to the velocity of the current squared plus the velocity of the velocity relative to the two velocities squared, and then 24 squared is equal to 7 squared plus VR squared. Sorry, and then VR is equal to 23 meters per second. And so going actually straight across, my speed is slower than it would be to go kind of with the current here, because it's up and to the right. So it is kind of going with the current here. To go straight across, I actually lose some speed. That's kind of interesting. And so one part, the next part of that question is, at what angle? So I also have to find the angle. And two sides that I know would be the velocity of the boat and velocity of the current once again. So I can say, and theta would be right there. So I know the opposite side, the hypotenuse. So I can say sine theta is equal to the O over the H. And then sine theta is equal to 7 over 24. And then I can say theta is equal to the sine inverse of 7 over 24. And then theta is, and theta is equal to 17 degrees. So there are my two answers. And then the last question is, how much time would it take you to get across? And using this VR from here now, it's just like the other problem. I would just do change in x. Change in x is equal to VT, and plug in 1,104 from what I was given is equal to 23 from my VR, 23t, and I find that the time is equal to 48 seconds. Don't know how that got there. Whoops. That's true though, but I don't know why it's there. I don't know who put that there, but so yeah. There we go. There's all my work, and thank you.